Hey there everyone, as an application on Snell's law, let's look at this example. As you can see, this example has a white light coming into a certain glass, and this certain glass has refractive index, and of course this white light, as you can see, disperses into two lights. One of them is red and one of them is blue. As you can see, the red refracts a little bit less than the blue, and that's normal because the red has a lower frequency and travels at a higher velocity in the glass than the blue, because the blue slows down more for its high frequency. So this is the angle of refraction for the red, and this is the angle of refraction for the blue. The red refraction index for this glass is 1.33, and the blue refraction index or refractive index is equal to 1.4. Okay, I need to mention that this distance here for this glass block is 4 meters. So the first part of this question is to find the angle between the red and the blue light, and this is what we're looking for. We need to find the angle between the red and the blue light. So first of all, the strategy is to find the angle, the refraction angle for the red, and then find the refraction angle for the blue and subtract the blue from the red. We need to know also that for this problem, n for this light coming in air is almost equal to 1, so we can say it's 1. And it's coming here at an angle of 50 degrees. Of course, we don't care about this angle. This is the angle between the ray and the surface. We care about this angle, so we should automatically change into working on the angle of incidence, not the angle, this one. So to start this problem, let's find out the red refraction index angle first. So I'm going to do n1 sine theta 1 is equal to n red sine theta red. Now we know n1 is equal to 1 times sine 40 degrees is equal to n red, which is 1.33 times sine theta red. With some quick calculation, first of all, we have to divide sine 40 over 133 and take the tan inverse to find theta r, and we can do this calculation. So theta r is equal to 28.9 degrees. Now for the blue, we can apply the same equation. n1 sine theta 1 is equal to n blue sine theta blue. We just plug in the same numbers here because that did not change. 1 sine theta sine 40 is equal to nb, which is 1.4 sine theta b, which we will find. And then following the same procedure for here, we can find that theta b is equal to 27.2 degrees. Okay, so we found theta r to be 28.9 degrees and theta b is equal to 27.2. Now to find this angle, I'm going to call this delta theta. Maybe I should use the green. Delta theta. Okay, so delta theta should be equal to theta r minus theta b, and that should be equal to almost 1.7 degrees. You might find it a little bit more or less, okay? Alright, depending on how many approximations you did for the sine theta calculations. Alright, now the second part of this problem is to find the length of this distance. So basically, part B, find green length. Let's say find the green length here. Okay? Okay. If we look here, we know that this is 4 meters long. Okay? We found this theta for r. So we can say tan theta r is equal to the opposite, which is the red one. So I'm going to call it the red. The opposite, which is red, divided by the adjacent, which is 4. Okay? Now, you know what theta is. It's 228.9. Plug that here, so find the value of tan 28.9, multiply it by 4, then you will get the red distance, or the red length is equal to 2.21 meter. Okay? Now use the same strategy for the blue. Okay? So you can say tan theta blue is equal to the blue length, which is this one. Okay, I'm going to call it blue, divided by the adjacent, which is 4, the same number. Solving for the blue, you will get blue is equal 4 times tan theta blue, which is 27.2 degrees. So tan 27.2 degrees times 4 gives us the blue, and the blue is equal to 2.06 meters. Okay? Now, if you want to find the green, just subtract the blue from the red. So green distance or length is equal to the red, which is 2.21 minus 2.06, and this is almost 0.15 meters. All right, and that's it for this problem. Thank you.